All right, good morning, class. Welcome to the science seminar. Our speaker will be back in just a minute, but just a few things to remind you of before we get started is that next week our seminar will be on the topic of organic chemistry using microwaves and bleach. It's brought to us by our own Karen Kubacek. Kubacek here. No? This is on very well. Rory Moffat. There he is. Hey. Hey, Moffat's up there. There he is. Okay. And Dr. Hathaway. Dr. Hathaway. Hey. Okay. And then 2 weeks from today, we have another building seminar. Smart buildings that utilize photovoltaics in generating all required energy. So maybe we can outfit our entire buildings here that learn how to generate enough energies for themselves. That would be a smart thing to do, wouldn't it? Okay. And that'll be from John Vaselli. He's from the UT Texas, Tyler, over there. And he's going to be talking to us about that. We have a number of buildings that they built that actually work this way. And then the last seminar in November will be on insects in horticulture production. So all you bug people who wonder what those bugs are that are crawling around your dormitories, bring them in that week and maybe they'll be able to be classified and determined what they are. But today, we're not talking about bugs, we're talking about buildings. And we have with us Dr. Eddie O. And Dr. O has his PhD from Iowa State University, which is sort of a friendly rival to where I earned my PhD, the University of Iowa.
Oh,
yes.
Hawkeyes.
Mm-hmm. Hawkeyes versus Cyclone. Yes.
Yeah, Hawkeye always win. I know that. Cyclone sucks, I know. That's why I'm not a big fan of football.
Yeah.
I'm so disappointed.
But as Melinda will tell you, Melinda Hoyt, she here today. So we did spend some time at Iowa State for the past few summers at games left.
Oh.
So we can talk about that later.
Nice.
Okay. Right. And I think you also have your master's from Iowa State?
Yeah.
Yep. And you have your undergraduate degree from a school in South Korea?
South Korea, yep.
Okay. So Dr. O comes to us from distant lands, Iowa, foreign country. Gotta get a visa to get into Texas. Come to Iowa. So, he is quite accomplished for a young scientist. He has numerous publications here listed. Okay, and he seems to be an expert on asphalt.
Sort of.
Sort of an expert. So if you want to figure out how you can make that Tyler parking lot smoother, maybe we'll have to talk to Dr. O here after the lecture and join us for lunch. We'll be having lunch in the Joyce Room. So if you're a civil engineer or someone like that, or someone just wants to learn more about South Korea or Iowa State or things like that, please do join us for lunch. Okay? Don't feel you have to know everything about the topic. Just come and join and have a friendly, personable conversation with our speaker and show them what warm people Laterno students are. Okay, so without any further delay, let's welcome Dr. O.
Well, thank you very much for this wonderful opportunity. And before I forget, I'm going to keep my tab open, the cafeteria, after lecture or seminar, so everybody come and just order whatever you want to order. Yeah, I get reimbursed from Dr. Gary anyway. So.
He's a joker, isn't he?
Okay, well, I didn't know much about the Toronto University until recently. I had to study some, and then I heard a little bit from some of my colleagues at the A&M Commerce. And what I found the fascinating fact is it's Christian-based university. Is that correct?
Yes.
Yeah, I love that. I mean, well, I still don't know how to pray, but at least my Friday night is some sort of a self-theology study. So I always set a couple of hours aside, and Friday I just read, systematic theology or whatever. And I got the brochure actually from the Dallas Seminary, and because I was thinking about joining online class or something, but oh well. So I feel very comfortable here. Feels like everybody's my brother, sister, cousins, nephews, or whatever. Not my son though. My son is only 9, fourth grade, but he's smart enough. But he wants to be a chef, so way to go. But anyway, so what I know is you guys are pretty much in the science and engineering area. Okay, so if you are, because my background is civil engineering and construction engineering, but to have everybody's interest together, what I want you to do is while I'm explaining my research / specialty area, you think about how the fundamental, the basic sciences or math will help the engineering overall. Okay, that's another way to look at my presentation today. Okay, because as you know, engineering overall is applied science, right? And without science, say physics, math, biology, chemistry, and all those, engineers like me, we cannot do anything. Because those are the basic tools we need. And the materials too. So, my background or specialty is pretty much pavement, highway construction, not your driveway. I mean, you can do your driveway. Because what I'm saying is there are different categories in terms of the road construction. Now the driveways in your backyard, that's pretty much just you pour anything and you'll be okay. But the major highways or say Mosley Avenue, I mean the avenues and so big ones, we need to pay very careful attention to those things. So we have to approach very scientifically. Okay, so that's what I'm going to talk about today, and hope you will enjoy. And anytime, if you have questions or if you can understand this alien's pronunciation, just stop me and ask questions. Because I spent my first 30 years in South Korea, so my English is still, but you can understand. Okay, so this is one of the examples. And that's what it's kind of famous. It's a drunken road, what they call in Mexico area. And well, I mean, it looks beautiful. Okay. Now, the reason that I put this one up front is it'll be fun if you are riding like what, 4-wheelers or motorcycles or whatever. But say if you are driving your Corvette. You don't want to drive on that. Or we don't want to have this kind of road as our interstate highways, right? Because speed limit needs to be like what? 35, 40? So the whole transportation issue will become very serious if we have a highway, looks like that. Again, it's fun, but that's a different issue. So the highways that we are talking about is like this. Okay, obviously it is not in long view for sure, but same thing like commerce is tiny. Walmart, McDonald's, that's it. So you guys are in better shape. But so let's say Dallas area or Austin or San Antonio or Houston area. Well, this is what we are talking about. So if you think of this kind of traffic, okay, and if there is, I'm pretty sure all of you experienced already, there is like 4-lane closed because of the road construction, and you have to detour and all that. It's very frustrating, right? It's very frustrating. You're supposed to go at least 65 miles, but now you're moving like 10 miles or 5 miles per hour. It's very frustrating, but that's not the main thing. If we are looking at what we call the user cost, how fast, how efficiently we can deliver a freight here to there, because all the trucks, right? And that cost is tremendous. And also, just regular passenger car drivers, the gas mileage is totally different, right? If you just keep moving like 55 miles per hour, or you have to stop, go, and things like that. So there are a lot of usual costs related to that. And then, to accommodate those traffic problems, transportation guys, including me, we always come up with this crazy idea. Looks like spaghetti. So you gotta be at the right spot, otherwise you'll go Louisiana instead of Dallas. But that's what happened. So there's a lot of issues in the transportation area, which is one of the civil engineering and construction engineering area. So the best way to take care of the highway is, if we have plenty of people, then we can spray some water and get some logs and then take good care of that. And how long that's going to last, we don't know. But this is actually a picture from a Tibet area, and that's what they do, because they don't have enough, say, equipment, construction equipment. And I heard that the Letourneau is very famous for that heavy equipment. So you should know more than me. So today's pavement engineering, which is a small specific area under transportation, we are looking at like this. And this is from a federal highway. Just so you know, there's a federal highway, and then there's a state DOT, right? Department of Transportation. And then there's a county or district offices, and then there's a city offices, and so forth. So the federal highway is all the way up top, and they spend millions and millions of dollars to come up with a better way to design the highways and to maintain the highways. So instead of having, okay, we're going to put a new road here, or we're going to just resurface this old highway, and then just hoping it will last at least 5 years. No, we don't want that. We want to exactly predict how long it's going to last. This condition, smooth, nice surface, and we want 20 years, something like that. So that's a new approach, and in order to do or accomplish those goals, we have to look at so many different components. Now, as you can see, this here, the highways or the pavements are only the top portion of the road, right? Okay, and then under there, beneath the surface, we're going to have some gravels or crushed stone, and what we call the base course. And then a few layers down, we're going to have the original dirt, soils, and what we call the subgrade. Now, because of the properties of the soil and the aggregate, it is very important to have a proper drainage condition. We have to provide drainage. Otherwise, I mean, you think about, like a kindergarten. When you're very little, you play with the dirt and water. They don't get along very well. I mean, dry soils, they have certain strength. But once the soils are wet, then what? It's kind of muddy, smooshy. I mean, there's no way that soil can support the structure, including the vehicle, the traffic load on top. So the way I see the pavement problems, I mean, you can see because there are a lot of the local highways, back roads, the two lane, local highways. You see a lot of depressions, right? Okay, when you're driving, especially near the shoulder. Especially near the shoulder. Now, if I have one day, I can explain all those things mathematically, but just to give you a rough idea, that problem is because of the drainage. Okay, if we do not provide good drainage condition, then no matter how will well design the structure, it's going to fail pretty soon. And the other aspect that we have to look at is, do we want to use black top or white top? Which means porous cement concrete or hot mix asphalt. So that's another huge question that we have to answer. And then we have to look at the weather condition. Now I will get to that point a little bit later because that is very important. The highway construction is job site specific because we do not use the same material to build the highway in Minnesota and in the Florida. We use totally different material because of the weather condition. So that's another aspect. And of course, in terms of the constructability and all that, we have to look at the total cost, right? And the total cost, there are actually two aspects. One is the initial cost, which is construction phase, and then there is a maintenance cost. And the easiest way to compare the black top and white top is porous cement concrete. The initial cost is going to be higher because of the curing and all those aspects. Okay. However, the maintenance is going to be considerably less than the asphalt highway. Now, asphalt is very fast to construct. We just need one night, then the road will be open to the public next morning. And we just spray yellow paint, and that's it. But the concrete, we got to have a form because we got to make a slab, and we pour the concrete, and then we got to wait like 4 weeks. So there's a lot of different aspects we have to think of. So that's why the whole construction and maintenance cost becomes very critical. So here is a very simple definition of pavement structure from Federal Highway Administration. So simply this is a combination of surface courses, which means asphalt mixtures or concrete mixtures, and the base, sub-base courses, and which means mostly aggregates, and not sand but gravel size, placed on a subgrade, which is the original dirt, but well compacted, well prepared dirt to support the traffic load. Now, like I said, your driveway and I-20 is totally different in terms of traffic load, right? Your driveway, your car is it, right? Maybe your parents' car too. But I-20 is a very heavy semis, right? So that will make a huge change, and we'll get to that point in a minute. So in overall, this is how I define pavement design. This is just sort of my way. So we're going to have a surface, and we're going to have some sort of in-between layers, and then we'll have a dirt. Now, the numbers that we have to play with, or the design variables, are these. And the constraints, the design constraints are those: traffic, environment, and time. Now, since you guys are smart, working hard, that's you. That's you.
Thank you.
Anybody can tell what is that E means? Anybody can guess?
The modulus of elasticity.
Can you speak up a little bit for other students?
It's the modulus of elasticity.
Have you heard? What about that sort of? Okay, so that's good. Can you explain?
It's the rate of stress over strain for the material.
Got it? It's very simple definition, probably, physics, you should have those concepts, and engineering, regardless of your major, either statics or mechanics of material, that area, yeah, you should learn those concepts. But, so there is a modulus, and the modulus basically means if we apply a certain type of loading condition on this material, how this material will behave or respond. And the relation is defined by a modulus. But this case, we're going to just use a Young's modulus, which is based on the simple Hooke's law for the simplicity. And then there is a mu, that is the Poisson's ratio. Everybody heard again? The Poisson's ratio is if we stretch a material, the length will be increased, right? Just think about a rubber band. We can stretch, the length increased, then what happened to the cross section or the diameter of the rubber band? Getting slimmer, right? Same thing. If you squeeze something hard, then it's going to bulge, right? The material. That is the Poisson's ratio. So three-dimensional material deformation, we can use this Poisson's ratio. And then we can change the height of each layer. And we don't need a height for this because this is some sort of infinite, right? All the way to core, mentors, or whatever. So, as long as we can come up with right numbers and the material to satisfy those conditions, that's going to be a good highway. That's going to be a good pavement structure. Now, because we didn't know much, so the first thing the people did, so 1950, 52, and 60, that area. So they just built a test section. And you can tell by the equipment, pretty old. We could put cows and horses right next. It'll be same though, okay? So, the Federal Highway and then AASHTO, what we call that organization, they built lots of test sections. And then there was a full-time truck driver. Just like NASCAR, Indy 500, whatever. They just do, their job is just driving the truck again and again and again on the circuit. And then, once in a while, engineers will go and check what kind of damage we got and how many passes of this truck we have, those things. And then try to correlate between the environmental condition and the loading condition, I mean traffic loading with the damage. So we can learn. So that was the initial stage. Now, the one thing we need to remember, the pavement design is very different. Okay, there is no certain or perfect highway. Now, most of engineering projects, we have a certain goal. Now, for the roads or highways, it is very hard to say what is the goal. So, number one is the pavement structure deteriorate gradually over many years. Hopefully many years, not next year. So, we have to predict what is that deterioration rate over the next 15 years or 20 years. And then decide when we need a major rehabilitation or resurfacing or any kind of maintenance necessary. So we can budget those things. And the other thing is, this one going back to the first picture that I showed you, there is a structural condition, but at the same time, there's a functional condition. So what that functional condition means, how comfortable the drivers, the users, would feel when they are driving on the highway. So again, it's very subjective, and most important thing is we cannot really define failure. What is a failure? Somebody can say, well, when there's a crack, well, that's failure. But somebody say, well, I don't care, I can drive on it. Now again, if you're driving F-150, you can just go anywhere, pretty much, right? You don't need a highway, or you don't need a smooth surface. Who cares? You can just go, and that's the road, right? That's the definition of road. But again, if you have a really nice, smooth racing cars or something, you don't want to go where you cannot get satisfactory functions over there. So it's very subjective and hard to define the failure. So there has been a lot of discussion and the research over that, but the way we learn or the way we answer those challenges in pavement engineering is, first, we look at what we call the failures or the distress conditions. Now, you are very familiar with all these, right? You've seen this already. Maybe not this, because Texas is kind of warm area. Okay. Now, what is that one? Alligator. Really, the name is alligator cracking. Yeah. Maybe crocodile. I don't know. I don't know the difference. And that is the fatigue behavior. So you can see that, number one, that problem happens when the surface is old. So the color is like a grayish. It's not really black. Okay? And it's been there for a long time. Then you will see those problems. The other problem, which is very common in the warm climate, is rotting. And the worst one that I had was somewhere in Missouri, and it was like a railroad. Once you get on it, just stay there. It's automatic drive. You are in there already. So like next 20 minutes, just set the cruise and take a nap or whatever. I mean, some states or some roads are really severe. They suffer with this problem. And then there is a tensile cracks, and you can tell because the crack, the direction is perpendicular to the direction of the traffic. So it is not a fatigue cracking, it is a thermal cracking, what we call it. And this happens a lot in the cold climate. And then, of course, we can see those what we call the bleeding. Some asphalt bleeds up in the stay day. So it's very shiny. In the sunny day, you can tell. And then there's always the pothole problems and so forth. And this one is a very special case because we have a failure of old concrete pavement underneath this asphalt pavement. So we look at these the failures first, and also for the white top. It looks familiar, right? Okay, we look at all these problems, including D cracking. The shape always looks like D, including the D cracking, and we have the fourth elevation failure. Then we have a punch out. But as you can see, most of the problems are near the joints between the slab. Now here's the pop quiz for your extra credit. You're not taking my course, but okay, why? Why do we need a joint for concrete pavement? Can we make it just one huge slab so it will be very smooth? Because the problem that with the concrete pavement is when you are driving on the concrete pavement, you can hear thump, 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 thump regularly, right? And that's because the tire hits the joints, right? And it's sometimes very annoying. But there's nothing much we can do. We need to have joint. Now why?
Thermal expansion.
Thermal expansion.
It expands and contracts based on the weather.
Perfect. You should get an A. So come take my class, I'll get you A. It's only 2 hours away. Okay, exactly. Now, material or any structural member will fail without any loading condition just because of the temperature, right? That is the thermal stress, what we call. They want to expand when the temperature is high or the humidity is high, right? Any material on this planet. They want to shrink just like our body or skin when the temperature is low or when it's dry. If they cannot do that volume change, if something prevents that volume change, then that stress will cause a problem, right? And that becomes a cracking. So we need to put engineered cracks. And that is joint. That is joint. And we have jointed this way, we have jointed that way. To prevent those problems. Yeah, it's just like, action, reaction, those things in physics. Okay? And overall, this is how we look at the structural design of two different the surface cores. So left side is asphalt concrete mixture on top, and the right side is a Portland cement concrete slab. So although the layers, underlying layers might be similar, the mechanism or the stress distribution below the top surface cores is very different, because asphalt is not very rigid. It will just distribute all the traffic load through all the way to the soil, the subgrade. However, concrete slab is very rigid. It's very stiff. So it will take care of most of the traffic loading. And then this one can sit on directly on the subgrade. Sometimes, well, it depends on the traffic condition. We don't really need the inter layers in between the top and the bottom dirt. So the challenge again is how that will spread, how much it's going to spread. Okay, so we have like your passenger car, what, 30 psi, 32 psi, higher pressure normally. So we have 32 psi on top, right? That contact point. Now how many psi is going to be here? We need a serious math, right? You were taking calculus, differential equation, linear algebra, all that, right? No, not really. You will need those to do this. Now, one of the things that, I don't know, I mean, maybe all you guys are seniors, but yeah, I've been at a few universities like past 13 years, and my frustration is always the lower level students who's just taking mostly university studies, what they call, not the major course, but they gotta go through the physics, chemistry, calculus, and all that. So now they can take engineering course, right? Or any major course. Now the problem, the student, say freshman, they can get easily lost. It's boring. I want to do something in my major. But the advisor said, no, the prerequisite is this, you gotta wait 2 more semesters. Now, if you guys remember, or somebody tell you why you are taking those courses, the subject shouldn't be that boring anymore. For example, I have 32 psi on top, and then I have 12 inches asphalt and then I have, say, 32 or 30 inches of aggregate. Now I have this soil. How many PSI is going to be here? So we can prepare the subgrade that can support, let's say, 5 PSI. If the soil cannot support 5 PSI, then what? The whole thing is going to fail. Is that right? That's why you are doing math, differential equations and all that. Okay, remember, it's coming. Okay, senior years or graduate school, you will need those tools. Okay, now this is some sort of idea. I don't know why I did that. I hate those. Excuse me, I'll be giving you one shot. So we've been in this era, and then 2000, exactly, 21st century, we moved to here, what they call mechanistic empirical. So we're using heavily rely on the material behavior that we can predict and we can test in the lab. However, in reality, because of the correlation, we need a little bit of empirical relation at the end. Now, somebody said, well, we're going to be a purely mechanistic design coming, but I'm not a big fan of that era. I mean, this is good enough for me. I mean, there are different aspects, but me is very practical engineer aspect I have. So overall, the flow chart looks like this. So we look at the conditions and we gather all the inputs and then we process those things, and there is the structural responses like sigma, epsilon, delta. We use a lot of Greek symbols, right? And my students hate those. And why don't you just give us a numerical number? No, you gotta use symbols so you can generalize the relation at the end. Okay, so or you cannot use calculator from instructor point of view. But anyway, so once we have those, we're gonna check all the distresses that I showed you the pictures, how they're gonna happen in how many years later, and then we're gonna check the smoothness too. If it's not smooth enough, then that's failure. And each state the state DOT has a slight different number to measure this, the standard. And then if something is not right, then we're going to go back, of course. So simple flow chart for that. And then, speaking of this hot mix expert, especially somebody from chemistry area, and I believe you guys know much more than me on this topic. Asphalt, the liquid asphalt, the crude oil refinery process, and basically the scum at the bottom, that's asphalt, right? All the good ones on top, there's gasoline, kerosenes, and all those, right? Refinery process, you gotta go to Houston, then you will learn. And then at the bottom, there's a scum, and that is asphalt, and we are recycling that as a construction material. Okay, and as you can see, by weight or volume, aggregates are the majority. Then we have a little bit of asphalt there because that's the glue holding the aggregate together, and then there are some air voids no matter what. And by changing these components or the physical, chemical properties of each component, we can make a totally different material. We can make a material that will last on I-20 for the next 30 years. Or it's just good enough for your driveway. Same material, but slight different way to design that mix. And that's where the engineers plays a really important role. And just key aspect of the liquid asphalt is, have you heard this viscoelastic material? I know some of you are in material area too, but and somebody say viscoplastoelastic. So asphalt is a really funny animal. So it's got that elastic component, it's got a plastic component, and it's got the viscous component. All those three properties together. So how we're going to handle that situation, that is a challenge. And the other thing is, the asphalt getting old. It's going to get white hair. When it's young, it's black, right? Next year, 10 years later, they're all gray. They age. So we have to know how fast they're going to age too. And the other thing that I want to point out is summertime, wintertime. Say 100 Fahrenheit and 30 Fahrenheit, the behavior is different. Elastic component or viscous component, which ones dominate, that depends on the climate. And that's why we have to look at the site condition. And then aggregate, obviously, one of the big thing about the aggregate is you can just look at this. Now I have two aggregates. One is crushed stone with a very rough surface. It's crushed from the quarry. The other one is from a river, dredged and dried. They are tend to be very round, right, and smooth. When it comes to what we call the shear strength or the supporting strength, this one can fail easily or easier than that one. Can you imagine that, the relation? Of course, after your enough math, physics, you can use an equation for that. Right now, you just understand the concept. So, this is how we're going to look at all those, what we call the molecular failure envelope. So, there is a component that we can expect from the cohesion, the stickiness of the asphalt. And then there is another aspect that we can get the friction from the aggregate. So we can play with those variables to make the best material. So basically, you are coming up with your own recipe, best recipe that everybody will like. However, another constraint is you have to use locally available material because this is engineering, right? Okay. Now, Georgia, they have a lot of granite, which is the strongest or the best aggregate. And like Iowa, they have lots of limestones. They are very soft. They are very weak. Now, if we want to use granite for the construction in Iowa, then we have to haul all those aggregates from Georgia to Iowa. That hauling cost is going to be tremendous, right? So we have to look at all those aspects and try to use locally available material as much as possible to reduce the cost, because engineering at the end is all about the cost. We can design same thing but so many different ways, what we call the alternative design. At the end, what's the answer? Which one costs less? Okay? So that principle applies to any kind of engineering area too. So we are trying to use the locally available material and find the best recipe. And some of the interesting new, relatively new, they are getting very popular, relatively new material is the roller compacted concrete. So what that means is, you know concrete, right? It's kind of oatmeal. There's some aggregate, but it's a cementish gray water together. But the roller can sit on that mix and then compact that mix. So it's very dry and stiff concrete mix. Just right after, the mixer discharged on the surface. And the other one is, interesting thing is the porous asphalt mixture. You can clearly see we pour the water on top, and this side is porous asphalt mixture, and this side is regular asphalt mixture. porous asphalt mixture, we put the aggregate particle size, we arrange that one very carefully, so we'll have a interconnected, basically holes, while holding a strong enough, okay, stiff enough mixture, so the water will drain all the way down, and then meet the drainage pipe and go to the ditch or somewhere. The problem with the asphalt is, you cannot drive, or you don't feel safe when you're driving on an asphalt road when it's raining, right? At night. And you got lots of splashes from, that bastard in front of us. You're gonna get some mud, rag, or whatever. So anyway, there is nothing much we can do. So to answer the question, we have this. So there's lots of research and studies going on to answer every aspect. And of course, all these are done by what? People like you, right? You pick your career path. And sometimes right after your bachelor degree, you want to go, get a job, get married, have kids, or some of you will go to graduate school and work on your master program or PhD program, and then you'll come up something like this. That's going to be your one of many possible dissertation options. And you can contribute to society a big time, don't you think? I mean, that's what this education is about. I know it's deep, so. So, any questions? Any questions? Except the North Korea. I have no idea about that country. I'm from South Korea. Yes, sir.
I'm a civil engineering major. And
Okay.
I'm actually just learning about pavement right now in construction engineering. I was wondering, for the porous asphalt hot mix,
Right.
do you find that there's a significant decrease in the strength of the material?
Well, strength will decrease. It's not going to be same as a regular, but the challenge is that's our homework. We have to make it strong enough for a certain condition. So, for example, if we have this porous mix, hot mix, and no matter how hard we try, we cannot make it really strong enough for interstate highway, then what? At least we can use on the street or avenue or parking lot. There's lots of different uses. And that's another thing that as a student we need to develop, some sort of think outside the box. Now, one of the interesting research that I was get involved was everybody has toilet, right? Okay, ceramics. At some point, you have to replace it. Okay. Now, one of my area was, can we recycle that broken ceramic tiles or toilets as an aggregate to make hot mix? Of course, possible. But it is not really strong like granite, right? So we cannot use for interstate highway, but that's good enough for university parking lot. Same thing with scrap tires. I forgot, but it's been like 7-8 years. So another research that I've done, United States, we're getting so many scrap tires every year, right? So what do? We got to find a way to recycle that material. And one way that we can use, McDonald's playground, it's got the rubber pieces, right? That's one way. People came up with that idea. And this area, we chop it down and use a strong magnet to get all the meshes, wires from the tire, and then we're gonna cook it. And that becomes what? Sort of liquid rubber, very close to asphalt. And then we use that one as an asphalt. So there's lots of different aspects. I mean, it's so fascinating, and I know your area will be too. You just need to stay strong and focused, and then by the time you graduate, you will find your passion. I didn't know what I'm doing when I was undergraduate, like freshman, sophomore, but I kind of got my idea by the time of senior year, and then I stayed there, and that's me now. So make sure you find your passion somewhere, and always your faculty advisor is the best one to ask questions, because they know the area. They are the expert, not you. Don't make yourself. Any other questions? I think the time is almost.
Last question. Okay, well, if there's not another question, our passion is going to become lunch here very soon. I would encourage you to join us for lunch if you're a civil engineer, okay? Talk more about things. And
Oh, I work up chemistry too.
chemistry.
Yeah, my father-in-law, he's a retired university professor, chemistry department. He worked so many years with Samsung, LCD, the liquid crystal area. That's why Samsung is so strong now. Sort of.
Let's thank our speaker one more time.
Was not that boring, right? No.